Yes, good evening everyone. In this lecture I am going to discuss about Townsend's theory. What is meant by Townsend's theory and what is the purpose of Townsend's theory? I am going to explain. Townsend's theory is used to find that means that whenever we are having a gaseous dielectrics, it means a gaseous dielectrics whenever we are having. That means the what we have we are having a dielectric. That means I am going to take here. I am going to having some gas dielectric. Whenever we are applying a high voltage, whenever we are applying a high voltage, a small leakage amount of current I naught will be going to a discharge. A small amount of current I naught will be going to be a discharge. That amount of current we need to find out. How we are going to find out that a small amount of current I naught is nothing but for that we have to derive. We need to consider here. I am going to consider this is an electrode anode we are having, and here we are having a cathode. Anode and cathode we are having. Here anode, and whenever we are having an anode and cathode, here the distance between these two we need to take it as a d distance. Initially the distance is x is equal to 0, and the distance here whenever we are doing it cathode, x is equal to d. X is equal to 0 and x is equal to d. So what will be happen to this case is nothing but how we are going to find out this value is nothing but we are going to find out ln of n naught is equal to A. That means ln equal to just we have to write uh, analysis of ionization process. 1 minute. Again, I am going to write here. This is an analysis of ionization process. The Townsend's theory is nothing but we are going to use for analysis of ionization process. Analysis of ionization. Analysis of ionization process. We call it as a Townsend's theory is nothing but an analysis of ionization process. When n electrons here in this case, whenever we are applying a high voltage, then automatically the values, the current will be flowing through these electrodes, positive electrode to negative electrode, so that n number of electrons will be going to run moves from positive to, that means an anode to cathode. Then what will be happen? For example, if I am taking a Townsend constant alpha n dx, that means just I am considering in these two electrons I am considering dx. This is an anode and cathode. The electrons will move from this point to this point is only a small distance of dx only will be moved. So total electrons will be moved from here to dx distance is alpha n into dx. Alpha n dx. That means the distance of alpha and dx elements will be going to be so that the total electrons will be moved is alpha n into dx. Alpha n into dx. So we are going to get from this dn by n is equal to alpha into dx. dn by n is equal to alpha into dx. If I am applying an integration on both sides, dn by n is equal to we are going to get alpha dx. So once if you are getting any like this, we can write this thing ln of logarithmic ln of n is equal to we are going to get alpha x plus a, alpha x plus a. From that, by applying an initial conditions, what are the initial conditions I told? When x is equal to 0, this is when x is equal to d. That means at cathode, whenever you are applying an high voltage, then automatically the electrons moves from the positive to negative. That means at initial condition x is equal to 0, and at the same time at x is equal to d. Now we are going to apply an initial condition, that is an ln of n naught. When here how many electrons will be there when x is equal to 0? N naught. When x is equal to d, we are having an nd electrons. Now In the place of by applying initial condition, by applying by applying initial condition, by applying initial condition, by applying initial condition, that is an alpha n of 0, sorry, alpha n of what we are going to get, alpha n of n, alpha n of n, n naught is equal to, we are going to get a. If I am applying an initial condition at x is equal to 0, that means an n naught electrons are there. When x is equal to d, we are having an nd electrons will be there. Now we can write this. Now what we are going to get, ln of n naught is equal to, we are going to get a. Ln of, by applying an initial condition, we are getting ln of n naught is equal to a, we are going to get. After that, now what is the first equation we are going to get? We know this equation, ln of n is equal to, we are getting this ln of a equal to alpha x plus a. So in the place of a, we need to substitute ln of n is equal to alpha x plus ln of n naught. ln of n naught. I am substituting in the place of a, ln of n naught I am substituting. Then after substituting, we are taking a simplification, ln of n minus ln of n naught is equal to alpha x is equal to alpha x. From this relation, we can get ln of n by n naught is equal to alpha x. ln of n by n naught is equal to x. From this, we can write e power ln of n by n naught is equal to e power alpha x, e power alpha x. From this, we can write, if I am simplifying this thing, then we are getting n by n naught is equal to, if I am applying an both side, if I am applying an Laplace logarithmic, then we are getting n by n naught is equal to e power alpha x. From this, n is equal to, we are going to get n naught into e power alpha x, where n is an total number of electrons and n naught we call it as an initial number of electrons. Initial number of electrons. This we call it as a Townsends theory or Townsends principle. Right? We are getting n is equal to n naught into e power alpha x, e power alpha x. And similarly, if I am going to calculate for I, that means when I equal to, similarly we are going to get I naught into e power alpha x. I naught into e power alpha x. Here I naught we call it as an initial current. We call it as an initial current, and I we call it as a total current. I we call it as a total current. X is we call it as a distance between the electrodes. X we call it as a distance between the electrodes. Distance between the electrodes. Distance between the electrodes. X we call it as a distance between the electrodes. Now, here the Townsends theory is a, we can consider in some cases what we can use I is equal to, in some cases we can take I is equal to I naught into e power alpha d. The d we call it as a distance between the electrodes. D we call it as a distance between the electrodes. I is called it as a total current, and I naught we call it as an initial difference, and whatever we are having an initial current. Whenever we are discussing a Townsends theory, is useful for a gaseous dielectric. We know that whenever you are getting some disturbances means the dielectric will be going to fail. The dielectric means the gas dielectric is some air. The air will be going to whatever. What will be happening when applying a high voltage here? Some electrons will be accumulated. These electrons are trying to move from anode to cathode. These electrons will try to move from anode to cathode. It will be going to move from anode to cathode. Whenever these electrons will be going to move to anode to cathode, in between the gas we are having some atoms. That atoms will be going to bombarding, and new electrons will be going to form. That process we call it as an ionization process. If in the ionization process, how much amount of some amount of the dielectric will be phased. That or if the dielectric will be phased means then automatically a small amount of current I naught will be going to be releases. That I naught current value how we are going to find out is nothing but according to Townsend principle we are going to find out. That means the Townsends according to each formula he is considered an initial and the final condition. What is an initial condition? He is taking the distance between the two electrodes he is going to consider D. This is an electrode, that means an anode and cathode. The distance between these two is considered a D. That is nothing but at x is equal to 0 and this is at x is equal to D. At x is equal to 0, how many electrons he considered? That is an n naught electrons, and similarly at these two particular condition he is considered Nd. After that he is taking an dx. That means he is taking considering a very small distance dx. If the electrons will be going to move a small distance of dx, then how it will be going to take? It means dx is equal to, consider dn is equal to alpha n into dx. From this relation, we are going to get what finally we are getting the total number of n is equal to n naught into e power alpha x, and finally we are getting I is equal to I naught into e power alpha x. Okay, this is the finally what we derived by a Townsend constant is I is equal to I naught into e power alpha d. That is an Townsend's theory principle. That means by using this formula, how we are going to find one problem we can find, how we are going to do that analysis. The problem is that in an experiment, I can write here the problem. In an experiment, in an experiment, in a certain gas, that means in an experiment in a certain gas, gas is nothing but any type of dielectric we can take. It was found that steady state current, it was found that steady state current, it was found that steady state of 5.5 into 10 power minus 8 amperes, 10 power minus 8 amperes at 8 kV, at a certain distance of, at a certain distance of 0.4 centimeter between the plane electrodes, keeping the field constants, keeping the field constant, the distance is reduced, to 0.1 centimeter, results a current of 5.5 into 10 power minus 9 ampere, then calculate alpha. This is the problem, right? It's given that in an experiment, whatever he done, Townsend's he done some experiment. In that experiment, what he is going to decide that what he done is just in the first case, two electrodes are there, two plane electrodes. The distance between these two electrodes is 0.4 centimeter. D1, consider D1. Now, at the time, the current I1 is equal to how much we are going to get? 5.5 into 10 power minus 8 amperes. 5.5 into 10 power minus 8 amperes. Same material, same gas dielectric you are going to use, same 8 volts only apply. In the second case also, each consider the distance between the electrodes, that is D2 is equal to how much is applied? 0.1 centimeter, 0.1 centimeter, and the I2 value he is applied at a same voltage, he won't change. 8. That means an I2 is equal to how much we are going to get? In this case, I2 value 5.5 into 10 power minus 9 amperes we are getting. I2 equal to 5.5 into 10 power minus 9 amperes we are getting. He not changed the medium, he not changed the apply voltage. What he changed, just he changed the distance between the two electrodes. This is the case 1 and this is the case 2. In the case 1, the distance between the two electrodes D is equal to D1 equal to 0.4 centimeter and dB equal to 0.1 centimeter and I2 is equal to, we are getting an 5.5 into 10 power minus 9 amperes. Now what he is asking, then we need to find out what is an alpha. Alpha is nothing but Townsend constant. What is an Townsend's constant? Now we are going to do this problem, how we are going to solve, right? Just to consider how we are going to solve. Right. Here, what is the value? We know that according to Townsend's principle, just now only derived a formula, that is I is equal to I naught into e power alpha d. I is equal to I naught into e power alpha d. From this, we can write I1 is equal to, we can write I naught into e power alpha d1. And similarly, we can write I2 is equal to I naught into e power alpha we can write I1 is equal to I naught into e power alpha d1 and I2 is equal to I naught into e power alpha d2. From these two, if I am taking I1 by I2, I1 by I2, if I am taking, then what we are going to get? I naught into e power alpha d1 by I naught into e power alpha d2. So I naught will be going to be cancel. So we are getting e power alpha d1 by e power alpha d. E power alpha d1 by e power alpha d. From this we can write I1 by I2 equal to e power alpha into d1 minus d. E power alpha into d1 minus d. Now we need to substitute that values, all values. What is an I1 value? I1 is 5.5 into 10 power minus 8 divided by I2 is 5.5 into 10 power minus 9, which is equal to e power alpha into d1 value. d1 is 0.4, d2 is 0.4, alpha into 0.4 minus 0.1. So we are going to get this value will become 7, which is equal to e power alpha minus 0.3. If I am applying logarithmic on both sides, then we are getting an alpha value. Alpha is equal to ln 10 divided by 0.3. ln divided by 0.3. If I am simplifying that same thing, then we are going to get 7.675. The units are tar to the power of minus 1, centi to the power of cm to the power of minus 1. Tar to the power of minus 1 and centimeter inverse. These are the Townsend theory, whatever we are having, right? The value, how we are going to find the alpha value. That means an alpha, we called it as a Townsend's primary ionization coefficient. Townsend primary ionization coefficient. That is an alpha is equal to, finally we are going to get 7.675 tar inverse into centimeter inverse. We are going to get. Similarly, here what is the change done an experiment is that he is considering two cases. The first case is he is placing them the same distance. He is not changing anything. Only the change is the distance between the two electrodes. If the distance between the two electrodes will be changes, automatically the amount of current value will be going to change. He is applying the same voltage, 8 volts only he is applying, and at the same material, on the same dielectric material, whatever the gas is, SS, SF6 or if he used any 8, The same thing only he used, and finally we are getting an alpha value like this. We are having a different number of problems like this. Just only the change is d1, I1 and I2. We know this value. Just we are going to write I1 by I2. The next one we are having a limitations of next we are having limitations of Townsend's theory. Limitations of Townsend's theory. What are the limitations of Townsend's theory? According to Townsend's coefficient, alpha is directly proportional to E by P. We know that in Townsend's theory, the alpha is nothing but only the Townsend's primary ionization constant. The Townsend's primary ionization constant is directly proportional to E by P. Here, where E we call it as an electric field, and P we call it as a pressure. He told that the alpha is directly proportional to E by P, but there is no explanation about regarding this thing. That is the main drawback of Townsend's theory. And the second case is it is applicable for uniform electric field. It is applicable only for uniform electric field. It is applicable only for uniform electric field. Right here, this Townsend's theory. Whenever almost we are not having all the uniform electric fields, the electric fields will be going to varies. If the medium will be going to change, or if the applied voltage will be going to change, the uniform electric field will be going to continuously varying. In that case, this will not going to be a value. And next one, the third point is it is having a more number of assumptions. It is having a more number of assumptions. We are having a more number of assumptions will be there. Why? Because whenever we are deriving this Townsend's theory, we are considering a primary, that means an initial conditions, and secondary condition like that we are going to consider. And next one, the dielectric breakdown. The last one is the dielectric breakdown. Dielectric breakdown will be depends upon what are the dielectric breakdown will be depends upon the different things. That means the first one is the nature of elements. Which type of elements we are going to take. Next, pressure. Next element is pressure, humidity and temperature, and then it will be having a different the breakdown. The dielectric breakdown will be depends upon all these following things, right? These are the limitations of a Townsend's theory. First, we have to know that what is meant by a Townsend's theory, which type of dielectrics. It is an analysis of ionization process, right? How that analysis of ionization will be occur. That thing we have to learn by using a Townsend's theory or Townsend's principle, and the limitations of Townsend's. These are the different types of limitations of Townsend's. Okay, right? Thank you. The next lecture we will discuss about that.